Hi all. So, in chapter 12.1 we consider double integrals over rectangular domains, but in chapter 12.2 we consider double integrals over non-rectangular domains or non-rectangular regions. Now, here is our first example. We want to solve this double integral x squared plus y over the region R, and our region R is the domain bounded by these two curves, the y equals 2x, which is a straight line, and the parabola y equals x squared, and our region R is this. Okay. Now to solve this problem we can use either type 1 or type 2 double integrals. Okay, so this is type 1. We have x squared plus y. Now, in type 1 the order of integration is dy dx. In type 2 the order of integration is dx dy. Again, if you use type 1 integral, then this dA equals to dy dx. If we use type 2 integrals, then this order of integration goes like this, dx dy. Okay. Now, first what we need to do is we need to figure out these 4 limits. Now, let us go back to the domain of integration. So, our domain of integration is bounded by these two curves y equals 2x and y equals x squared. Okay. Now, the first thing that we need to do is, of course, sketch the domain and then figure out the coordinates of these two intersection points. Now, okay, let us figure out the coordinates of these two intersection points. To do that, we set x squared equals to 2x. We have a quadratic equation. Take all the variable terms to one side. So, I took 2x to the left hand side, it becomes negative 2x. Now, we have a quadratic equation x squared minus 2x equals to 0. To solve this, what we can do is we can factor out x, then you will get x times x minus 2 equals to 0. Now, we have a product that equals to 0. This means either x can be 0 or x can be 2. Okay, so, x equals 0 corresponds to this point. This is x equals 0, and this is x equals 2. Okay, good. Now, what we can do is we can find the corresponding y coordinates. Okay, when x equals 0, pick any equation. Okay, I am going to pick this one. If x equals 0, y equals to 0. If x equals 2, y equals to 4. So, this y coordinate is 4. Okay. Now, let us go back to this type 1 double integral. When we set up this double integral, what you need to do is first find the limits of this outer integral. Those limits, these two limits must be constants. Okay. Now, if you think about this outer integral corresponds to the x variable. Now, your x goes from 0 to 2, that is it. Next, we need to figure out the limits of this inner integral. To do that, what I usually do is I always consider a rectangular element like this. So, this is your dA. Okay. Now, what is the lower limit of y? Okay. Now, if you think about this element, we can move this element up to this height, and this height is given by y equals x squared. In other words, the lower limit of y should be x squared. And what is the upper limit of y? Upper limit of y is given by this straight line, which equals to 2x. Now, so these, if you think about these two limits, these are functions of x, because once you integrate with respect to the y, and if you apply these two limits, you will get a function of x, and then if you solve this outer integral, you will get a constant. Okay, now let's think about this type 2 double integral. Now my order of integration is dx dy. Okay, again let's try to figure out the limits of this outer integral. So this outer integral corresponds to the y variable, and y goes from 0 to 4. Y goes from 0 to 4. Now we need to figure out the limits of this inner integral. Now these two limits should be functions of y. Okay. Okay. So y equals 2x, and let's try to express this equation in terms of y. So y equals 2x will give you x equals to y over 2, and what is the equation of this one, this parabola, with respect to the y variable? It should be, so if you solve for x, you will get y equals to plus or minus square root of y. But in this region your x values are positive, so we can neglect the negative sign. Okay, now let's figure out the lower limit of this this inner integral. So what is the lower limit of x? Now if you think about this generic element, then we can move this generic element up to that line, which is given by y equals 2x, but its equation with respect to the y variable is y over 2. So this lower limit should be y over 2, and what is the upper limit? Upper limit should be given by this parabola, which has the same equation, x equals to square root of y. Okay, again this is very important. So when you solve double integrals, we solve from inside to out, and then however when we set up the double integrals, we go from out to inside, because always the limits of this outer integral must be constants. Okay. Okay, and now I am going to, so you can solve either type 1 or type 2 double integral, but you should get the same answer. Now in this example I am going to solve this type 1, and it will be in the next video. Okay. Okay, now welcome back to the second part of the video. Now previously what we did was we solved this, we started to solve this double integral x squared plus y over this region R, and our region R is bounded by the line y equals 2x and the parabola y equals x squared. Now in the previous video what we did was we set up this double integral using type 1 and type 2. Now in this video I am going to solve the type 1 double integral. Okay, now so here my order of integration is dy dx. It means first we are going to integrate with respect to the y variable and then with respect to the x variable. Okay, let's do that. Okay, so we consider this inner integral, which is integral from x squared to 2x of x squared plus y dy. Now my variable of integration is y. It means we have to treat x as if it is a constant. Okay, now integral of a sum equals to sum of the integrals. Okay. Now, if you integrate, now remember x is a constant, therefore x squared is also a constant. If you integrate a constant, then you will get that constant times the variable of integration. So, if you integrate x squared with respect to the y variable, you should get x squared times the variable of integration, which is y, plus, now integral of y with respect to the y variable is y squared over 2. Okay. Now, what is the lower limit? Lower limit is y equals to x squared, and the upper limit is y equals to 2x. Okay, I hope you all can see this is y. Okay. Now, let us apply the upper limit first. So, we have to replace each y with 2x. We get x squared times 2x plus 2x squared over 2, okay, minus the lower limit. Lower limit equals to x squared. So, you will get x squared times the x squared plus square of x squared over 2. Then we have dx. Of course, we have this outer integral. Okay, now at this point, it is better to simplify this integrand, and if you simplify this integrand, you should get integral from 0 to 2 of 2x cubed. So, if you multiply these two, you will get 2x cubed, plus if you square 2x, you will get 4x squared. 4x squared over 2 is 2x squared, minus, okay, so this is x to the power 4. Square of x squared is also x to the power 4, but here we have x to the power 4 over 2 plus x squared, which will give you 3 over 2 times x to the power 4, then dx. Okay. Now, as you can see, once we evaluate this inner integral and apply the limits, we have an integrand that contains only the x variable. Okay. Now, this is a very simple integral, and let us solve this. Integral of 2x cubed. So, 2 is a constant. Integral of x cubed is x to the power 4 over 4 plus integral of 2x squared. 2 is a constant. Integral of x squared is x to the power 3 over 3 minus 3/2, which is a constant, and then integral of x to the power 4 is x to the power 5 over 5. Okay. Now, of course, we need to evaluate this at x equals 0 and x equals 2. Okay. Okay. X equals 2. Okay. Apply the upper limit first, then you will get, so 2 to the power 4 is 16, 16 over 4 is 4, and 4 times 2 is 8, plus 2 to the power 3 is 8, 8 times 2 is 16, and we have 16 over 3, minus 3/2 times, now x is 2, 2 to the power 5 is 2 to the power 4 is 16, 16 times 2 is 32, so we have 32 over 5. And if you simplify this, you should get 56 over 15, and this is the final answer. Okay. Now, if you use the type 2 double integral, you should get the same answer, which is 56 over 15. Okay, with this I finished this example where we integrated this function x squared y over this rectangular, non-rectangular domain R. Okay, thank you.